What if you could step into a machine that lets you skip time not just a year or a century, but 5 billion years into the future? Like the portal in Tomorrowland, it doesn't promise paradise, only a glimpse of what comes next. You close your eyes, press the button, and the world begins to unravel. Skyscrapers melt into memory, forests burn, regrow, then vanish again. Oceans boil away into clouds of steam. In seconds, you're watching civilizations rise and fall like sparks in a storm of centuries. When you open your eyes, the future isn't chrome and wonder. The moon has drifted away. The sun has swollen, swallowing the sky in fire. Earth, once a blue beacon of life, now glows like a dying coal. But before it all fades, one question lingers in your mind. Did humanity survive? Or did we outgrow what it means to be human? This is not Tomorrowland. This is 5 billion years beyond it, and you're about to witness the final story of Earth. Embarking on 100 years from now, humanity will no longer look the same. Our cities will stretch beyond the clouds, wrapped in solar fields and orbiting mirrors. Artificial intelligence will handle the delicate balance of energy, weather, and medicine. Illnesses that once terrified us will be rewritten at the genetic level. We will slow aging, bend biology, and engineer life as precisely as we now design machines. But technology will not erase the scars we've left on our planet. The air will still carry the memory of carbon. The oceans will still climb, and the world's coastlines will look unfamiliar. By then, we will no longer fight the planet for survival, we will negotiate with it. Climate engineering will become humanity's greatest shared project giant. Atmospheric shields reflecting sunlight, carbon-hungry algae woven into oceans, and weather systems guided by quantum sensors orbiting above. When Earth begins to steady, our gaze will shift outward. Robotic probes will land on Venus, Europa, and Titan. The moon will become our first permanent outpost, its dusty plains alive with human light. Then, in the centuries that follow, we'll make the leap to Mars. By the year 2400, thousands of settlers will call the red planet home. They will terraform its atmosphere, melt its polar ice, and seed its surface with microbes designed to breathe carbon dioxide into oxygen. Orbiting mirrors will focus sunlight to warm the plains of Elysium. Slowly, the dull red fades to patches of green, a second Earth in the making. Meanwhile, Earth begins to heal. Artificial forests restore balance to the carbon cycle. Megacities rise vertically instead of outward, freeing land for ecosystems long erased. Humanity, for the first time, becomes a planetary steward rather than its conqueror. By the dawn of the fourth millennium, civilization reaches a milestone predicted centuries earlier. Type 1 on the Kardashev. Scale a species capable of harnessing every watt of energy its planet can provide. We control the wind, harvest lightning, and shape the rhythm of rain. The planet breathes with us, not against us. Yet beneath this triumph hums a quiet realization. We have outgrown our cradle. Earth was our beginning, not our boundary. Humanity is no longer a species tied to soil, but to curiosity itself and intelligence learning to build worlds from dust. And this is only the first 1,000 years of the journey ahead. 1,000,000 years from now, Earth will be a museum of humanity's origin. Continents will have shifted. Mountain ranges will rise where cities once stood. The poles will freeze and thaw in long, silent cycles, sculpting a planet that no longer remembers its first inhabitants. The last traces of modern civilization, our towers, our satellites, our monuments will have crumbled to dust, but humanity itself will still exist, scattered among the stars. By this time, our species will have split into countless branches, some born on Mars, others in the cloud cities of Venus, or beneath the methane skies of Titan. The line between human and machine will have blurred beyond recognition. Bodies will be optional. Consciousness will travel as streams of quantum data, inhabiting synthetic forms or digital ecosystems that span entire planets. What began as survival has become evolution by choice. Back on Earth, nature will reclaim the world. Glaciers will return, ushering in a new ice age. Supervolcanoes like Yellowstone will awaken, painting the sky in ash and fire, blocking sunlight for decades. But life will adapt, as it always does. The planet will cool, heal, and begin again just slower now, older now, quieter. 50 million years later, the solar system itself will change. Phobos, the inner moon of Mars, will drift too close to its parent planet and shatter, forming a faint ring across the Martian sky. On Earth, Africa and Europe will collide, birthing a new mountain range taller than the Himalayas. Deep beneath the crust, the planet's molten heart will rearrange continents into new configurations. By the 100 million-year mark, Earth will witness another visitor from space, a massive asteroid, one large enough to threaten the balance of life once again. But this time, no catastrophe will come. From the dark edges of the solar system, vast orbital arrays will respond, beams of controlled gravity bending the asteroid's path, redirecting it harmlessly away. Humanity, now watching from colonies scattered across a dozen worlds, will save its birthplace without ever setting foot on it. Earth will continue to turn, pale and aging under a sun that burns slightly hotter with every million years. Its oceans will retreat. Its skies will fade from blue to white, to the descendants of humankind. It will be both sacred and strange, a cradle they no longer need, but can never forget. And as they look back across the void, toward the tiny world that made them, one truth will remain constant. Leaving home was never the end. It was the beginning of forever. 500 million years from now, the sun will begin to betray its children. Its core, once calm and steady, will burn hotter, brighter, and larger from the surface of Earth. If anyone were still there to see it, the sky would look pale and washed out. The oceans would shimmer under a relentless glare, slowly boiling into the air. The great forests of the equator would wither first, followed by the polar caps that once anchored the planet's rhythm. Photosynthesis will falter, oxygen will thin, and the air itself will begin to suffocate life. By then, the descendants of humanity will have already moved on. Entire worlds, Mars, Europa, Titan will pulse with human-made ecosystems, sustained by machines older than memory. Dyson swarms will glitter around distant stars, capturing their energy like cosmic coral reefs. The solar system will be humanity's birthplace, not its home. Around this time, a distant star named WR-104 will explode into a supernova, releasing waves of gamma radiation across the galaxy. To the unprotected, it would mean extinction. But the children of Earth will watch from safety, sheltered behind light-bending shields and artificial magnetic fields. Technologies that once existed only in theory. Survival will no longer depend on chance. It will depend on foresight. 1 billion years into the future, the sun's brightness will have increased by 10%. The last traces of liquid water will vanish. Earth's atmosphere will collapse into a suffocating shell of steam and dust. No trees, no oceans, no clouds, only iron-red deserts stretching beneath a white, swollen sky, deep underground. Extremophile microbes might cling to life, but for all other species, extinction will have already come. And yet, life will endure, just not in the form we once knew. Humanity will have transcended biology entirely, spreading consciousness across networks of light. Our minds will travel between stars as easily as radio waves once crossed the air. The Kardashev Type 2 milestone, harnessing the energy of an entire star, will no longer be a dream, but a routine engineering project. Dyson spheres, stellar engines, and controlled orbit migrations will keep civilizations alive as they roam from one system to another. 2 billion years from now, even the galaxies themselves will begin to change. The Milky Way will collide with the Magellanic Clouds, stirring a storm of newborn stars and collapsing black holes. In this chaos, humanity will adapt again, reshaping orbiting worlds, transferring consciousness between galaxies, and guiding energy flows as if composing symphonies of creation. Back where it all began, the solar system will be unrecognizable. The sun, burning whiter and larger, will cast long shadows across the skeletal remains of Mercury and Venus. Earth will be a cinder, its crust cracked and glowing like cooled glass. But across the universe, countless descendants of the same spark that once lit up this small world will still be watching, remembering, and wondering. Because by this point, Humanity will have become something more than mortal, something older than planets and younger than stars. We will no longer orbit the sun. We will carry suns within us. 5 billion years from now, the sun begins its final act. Its hydrogen runs thin. The nuclear furnace at its heart falters, and gravity finally wins. The core contracts, heating until helium fuses into carbon. The outer layers swell outward, first slow, then unstoppable, from a distance. The sun blooms like a wounded flower, expanding into a red giant so vast that its fiery edge brushes the orbit of Earth. Mercury and Venus vanish first, swallowed whole by the growing inferno. Then, the light touches Earth. The crust liquefies. Mountains collapse, and the very air ignites. For a brief moment, the planet glows brighter than it ever has before, its final heartbeat made of molten rock and plasma. Then, silence. The Earth that once sang with oceans and voices is gone, reduced to vapor drifting through the void. Far beyond this dying light, humanity's descendants, if the word still applies, watch in quiet awe. They no longer have bodies. They exist as consciousness woven into the fabric of energy itself. Scattered across 1,000 galaxies, some have built artificial stars, others live within black hole halos, extracting power from gravity's edge. They remember the sun as their first home, a spark that taught them what it means to begin and to end. When the sun's expansion ceases, its outer layers drift away into space, forming a delicate halo of glowing gas, a planetary nebula, a cosmic tombstone floating in silence. At its center remains a single, white-hot ember, a white dwarf, no larger than Earth, but heavier than all its memories combined. It will shine faintly for trillions of years, cooling slowly until even its light surrenders to darkness. If you could stand where Earth once was, there would be nothing to see, no continents, no sky, no trace of blue, only the ghost of a star, flickering through the ruins of its own creation. And yet, far away, within the Dyson spheres orbiting distant suns, echoes of Earth still live. Human memory encoded in light, preserved in machine and mind, continues to travel, carrying the story of its origin across eternity. The sun dies, but the idea it sparked does not. From dust to thought, from planet to energy, from flesh to light, this was always the path. The universe did not end. It simply changed shape, and somewhere in that endless expanse, a remnant of humanity looks back not with sorrow, but with understanding. The journey home was never about returning to Earth. It was about learning how to outlive it. 5 billion years after its birth, the sun fades into a whisper of light, and Earth becomes a story written in stardust. But perhaps that's what life was always meant to be, a spark that learns to keep burning, even after the fire is gone. Humanity's legacy won't be carved in stone or orbiting satellites. It will live in the minds that once looked up and wondered. We were never meant to last forever, only to prove that life could reach for forever. And maybe, somewhere in that distant future, as galaxies drift apart and the stars begin to die, someone or something will ask, what if we could bring a dead star back to life?